If you've been trying to build a graph, you most likely looked online, you're most likely to stumble across something that looks like this, either describing an adjacency matrix or the better known adjacency list. Now, the issue with the way a lot of online sources are creating their adjacency list is that they're using, for example, a linked list or an array list to represent their graph. There's nothing wrong with doing it. It's just that it's not as efficient model as a hash map and a hash set. The benefits you get from this linked list are most likely not going to outweigh benefits of using a hash map and a hash set. As you can see down here, we have the efficiency comparison between the two. Better adjacency list is going to be running in constant time, whereas the adjacency list is going to be running in linear time. Lastly, and importantly, we're going to get data type flexibility with our better adjacency list, whereas traditionally online, graphs are viewed as being represented by integers. So we're going to dive into the code now, and here we see our graph class, and in line 9, we have our better adjacency list. And what's important to note here is that the rest of these functionalities within the class are no more complex than using an array list or a linked list. However, we're going to get increased efficiency and more flexibility because here we're using a generic data type, and so we can now pass in nodes of any object type and it will work as a graph that you can even search on. It could be any object and we can still search this graph. So that's basically it for this one. I just thought it was very interesting to learn about adjacency lists and then to also realize that the list functionality does not provide much benefit as it takes away in this problem domain of graphs, where the order of your vertices or your edges usually does not matter at all. And so basically you can build better graphs as long as we can get away from the idea that adjacency lists are actually lists.